prove that that's the first one. Prove that 1 minus sine theta times 1 plus sine theta all over sine square theta is equal to cot square theta. We start from the left hand side. You can either show that the right hand side is equal to the left hand side, or that the left hand side is equal to the right hand side. Now I am showing that the left hand side is equal to the right hand side. Left hand side is 1 minus sine theta times 1 plus sine theta all over sine square theta. That's the same as, we can see that 1 minus sine theta times 1 plus sine theta is a difference of 2 square. It's the same as 1 square minus the square of sine theta all over sine square theta. And that simply means, of course, 1 square is the same as 1, so we can just leave it as 1 minus sine square theta over sine square theta. And I know that 1 minus sine square theta is cos square theta. We can see that here, sine square theta plus cos square theta equals 1. That means if you make cos square theta the subject, cos square theta will be equal to 1 minus sine square theta. So instead of writing 1 minus sine square theta here, I'll write cos square theta. And that simply means cos square theta. That simply means that will be equal to cos square theta over sine square theta. And we know that cos square theta over sine square theta is the same as cos theta is the same as the square of cos theta over sine theta, which is equal to cot square theta. And that is the right hand side. And that's it, very, very simply. Don't forget how we got that cot theta is cos theta over sine theta. We already said that cot theta is 1 over tan theta, and we know that tan theta is sine theta over cos theta. This is a 1. And we know that tan theta is sine theta over cos theta. That simply means 1 divided by sine theta over cos theta, which is now going to be 1 times cos theta over sine theta, which is cos theta over sine theta. That means cot theta is also the same as cos theta over sine theta. So now, and the square of that will be the same as the square of cot square theta. Cot theta is cos theta over sine theta. That means the square of cos theta over sine theta is cot square theta, which is the right hand side. And that's it, very, very simply. Now we go to the second question, and that says prove that let's check that. Prove that 1 minus cos theta 1 minus cos theta divided by 1 plus cos theta divided by 1 plus cos theta is equal to, let me write that on the next line, is equal to 2 cot theta into bracket is equal to 2 cot theta into bracket cot theta minus cosec theta into bracket cot theta minus cosec theta plus 1. That's a question. Prove that 1 minus cos theta over 1 plus cos theta is equal to 2 cot theta into bracket cot theta minus cosec theta you close the bracket and you add 1 to that. Cot theta minus cosec theta plus 1 as shown here. Now this time I want to go from the right hand side. The right hand side, that's the solution, by the way. The right hand side is equal to 2 cot theta into bracket cot theta minus cosec theta plus 1. Cot theta minus cosec theta plus 1. And that is the same as, if I expand the brackets, that's the same as 2. If I open the brackets, that will be 2 cot square theta. This is cot theta. 2 cot square theta minus 2 cot theta cosec theta plus 1. And this is equal to, and that's equal to 2. I know that cot square theta is the same as sine square. No, cot square theta is the same as cos square theta over sine square theta minus 2 cot theta. That will be 2 cos theta over sine theta. Cos theta over sine theta is cot theta times cosec theta is 1 over sine theta, and you have this plus 1. And that simply means, now where do we go from there? Now that simply means we can multiply this 2 minus 2 cos theta over sine theta times 1 over sine theta. So let's write this first. 2 cos theta, 2 cos square theta rather. That will be 2 cos square theta over sine square theta. 2 cos square theta over sine square theta minus 2 cos theta over sine square theta plus 1. If you multiply this by this, you get this. And you add this 1. Now, what's the next thing to do? From here, we can find the LCM of the denominators. The LCM of the denominators, of course, you know that this is 1 over 1. So the LCM of the denominators is sine square theta. Now, sine square theta in sine square theta, or better still, sine square theta divided by sine square theta is 1. 1 times 2 cos square theta. That's 2 cos square theta. The next one, sine square theta divided by sine square theta. The next one, sine square theta divided by sine square theta divided by sine square theta. That's also 1 times minus 2 cos theta. That's minus 2 cos theta plus, now sine square theta divided by 1. That's sine square theta times 1. That will be sine square theta. So plus sine square theta, and that's equal to 2 cos square theta minus 2 cos theta. I can see that, I know that I don't need sine in my answer. There's no sine on the right hand side. There's no sine on the right hand side. They said I should show, there's no sine on the left hand side. I'm showing that this right hand side is equal to 1 minus cos theta over 1 plus cos theta. So that means there's no cosine in what I'm showing that this left hand side is equal to. So I'll find a way to get rid of this sine square theta. I'll make sure that everything here is in terms of cos theta, because that's the only trig ratio on the left hand side. So that's why I'm going to write this. That's why I'm going to write sine square theta as 1 minus cos square theta. You get that from sine square theta plus cos square theta equals 1. And the denominator too will be 1 minus cos square theta, because there's no sign in what I'm showing that the right hand side is equal to. There's no sign on the right hand side. Now that's equal to, there's no sine theta, sorry, on the left hand side. I'm showing that the right hand side, which is this, the right hand side, which is this, is equal to the left hand side, which is this. So I'm writing sine square theta as 1 minus cos square theta, and this one too as 1 minus cos square theta, because the left hand side that I'm showing that the right hand side is equal to doesn't have sine theta, it only has cos theta. So what do we do from, where do we go from here? 2 cos square theta minus cos square theta will be cos square theta. That's the same as saying 1 cos square theta minus 2 cos theta plus 1 all over 1 minus cos square theta. Now what do we do here? We can factorize this numerator. But how do we factorize it? Let's do it this way so that we don't get confused. The expression is cos square theta minus 2 cos theta plus 1. This is what I'm going to do. I'm going to make let A be equal to, cos theta. That simply means this expression will become a square minus 2a plus 1. The square of cos theta is the same as cos square theta, and if a is cos theta, that means cos square theta will be a square. Now we can factorize this easily. Plus 1 times a square, that will give us plus a square. Now what are the factors of plus a square whose sum is minus 2a? The two factors that you multiply to get plus a square and add to get minus 2a. That's minus a, and that simply means a square minus a plus 1, which is equal to, now this is how we usually go. You write the expression again. That simply means a square minus 2a plus 1 is equal to a square minus a plus 1, and that's equal to a into bracket a minus 1 minus 1 into bracket a minus 1, which simply means a minus 1 times a minus 1, and that's the same as the square of a minus 1. So that therefore means that cos square theta minus 2 cos theta plus 1 will be equal to a minus 1 times a minus 1, where a is cos theta. That means cos theta minus 1 all square, and I can write it as cos theta minus 1 times cos theta minus 1 if I like. They are the same thing. Now, so that's what we'll get when we factorize the numerator. That's what we'll get when we factorize the numerator. That simply means, let's take all of this out. So that means cos square theta, yes, that simply means cos square theta. That simply means, let's bring it up so that we can see it, bring it close to it. Yeah, so that simply means the numerator here, this numerator, is the same as cos theta minus 1 times cos theta minus 1. And you can write it as the square of cos theta minus 1 if you like. While the denominator is 1 minus cos square theta is the same as 1 square minus cos square theta, which means it is a difference of two squares, and that will be 1 plus cos theta, 1 plus cos theta times 1 minus cos theta. Now we know that the left hand side the left hand side is, let's check it again. What's the left hand side? 1 minus cos theta over 1 plus cos theta. So that means the numerator has to be 1 minus cos theta and the denominator has to be 1 plus cos theta. So we have to find a way of getting rid of this 1 minus cos theta and making the numerator 1 plus, no, I'm making the numerator 1 minus cos theta. So what do? I want to write 1 minus cos theta as cos theta minus 1. 1 minus cos theta is the same as 1 minus cos theta is the same as minus into bracket cos theta minus 1. Or let me write it this way so that you don't get confused. 1 minus cos theta is the same as minus 1 into bracket minus 1 plus cos theta. You'll see that if you expand this, you're going to get 1 minus cos theta. And that is the same as minus 1 into bracket cos theta minus 1. Cos theta minus 1. So instead of writing 1 minus cos theta here, I'm going to write minus 1 into bracket cos theta minus 1. So that simply means cos theta minus 1 times cos theta minus 1 all over 1 plus cos theta times minus 1 into bracket cos theta minus 1. If you like, you can also just write it as let's see that. If you like, you can just put only minus here and not put the 1. It's the same thing. Now I can bring this minus 1 outside here and write it this way. Cos theta minus 1 times cos theta minus 1 all over minus 1 into bracket 1 plus cos theta into bracket cos theta minus 1. And now that means cos theta minus 1 cancels cos theta minus 1, and I'll be left with cos theta minus 1 all over minus 1 into bracket 1 plus cos theta is the same as minus into bracket 1 plus cos theta. And that simply means minus, of course, if I say x over minus y, that's the same as minus x over y. So this will become minus into bracket cos theta minus 1 all over, let's take this out, all over 1 plus cos theta, and that is equal to minus cos theta plus 1 over, that's equal to minus cos theta plus 1 over 1 plus cos theta. And you can already see that that's the same as the left hand side. So that will be 1 minus cos theta over 1 plus cos theta. 1 minus cos theta over 1 plus cos theta, which is equal to the left hand side. And that's it, very, very simply.